Hey guys, welcome back to Amateur Artist, the all-in-one channel. And many of us, including me, have online classes. And some might not get the topic as well they're explained in school. Not me, but I get the topics. But this video is for those who do not get the topic as well as they're explained in school. So today, I'm going to explain Physics Chapter Energy for Class 7th ICSE syllabus. So, moving on to the video. So first, let's begin with this small introduction to physics. Physics, as all subjects, is the composite of the inventions and discoveries of many scientists. The most famous and also known as the founder of physics is Sir Isaac Newton. Now, moving on to the chapter concept energy. Sorry for the thing. What is energy? Let's begin with a small introduction to energy as well. Your phone, laptop, or your desktop through which you're viewing this video needs charging, right? Likewise, you need to eat food to run, to talk, etc. Right. Yes, so energy means the ability to do work. But what is work? To understand that, let's see a small example. If a scientist pays the person who does the most work, then he will bring a common man and a physicist. So the common man works 3 hours in his computer and the physicist just displaces a wooden block 2 meters in just 3 minutes. Who did the most work to you? Obviously, you would say the common man, right? But wrong. But scientists would say the physicist, because in the physics term work means the applied force must have some displacement or you did not do any work. Some movements, for example, if you push against the wall, there is no work done. English work and physics work are different from each other. And they differ a lot, so scientists did not want to change other names, so they added this, the same term, work. So what is work done? Work done is equal to force into displacement, which would be a very good thing for you to remember in numericals. Now, let's look into the different forms of energy. The most popular and most known energy is potential energy and kinetic energy. Potential energy, the energy possessed by an object due to its position or condition. Let's look at an example. If I lift this hammer to a position, it has potential energy. If I throw this ball up at a point, it has potential energy. The way to find potential energy is m into g into h, or mass into acceleration due to gravity into height. For beginners who do not know the value of gravity, it is 9.8 meters per second, or when you round it off to the value, you would get 10 meter per second, or 10 Newton per kilogram. So it'll be easier while doing equations, which I will post a video as part 2. Now moving on to kinetic energy. Kinetic energy is the energy possessed by an object due to its motion. Some examples of kinetic energy are a running man or a train traveling at high speeds. The formula for kinetic energy is half into m into v squared, which is half into mass into velocity squared. And velocity is nothing but speed in a given direction. But what about a bird? It is at height and also has velocity, which means it's flying in a direction. What do you call the sum of kinetic and potential energy? Yes, it is mechanical energy. There are, though, many forms of energy, such as heat energy, light energy, elastic potential energy, chemical energy, sound energy, nuclear or atomic energy, and many innumerable forms of energy. Let's look at some examples and definitions. Heat energy. Heat is a form of energy. We use heat to cook food. A gas stove converts the chemical energy to liquefied petroleum gas or LPG into heat. Examples are stoves, fire, the sun, etc. Light energy. Light is a form of energy. It enables us to see. Plants use energy of sunlight to carry out photosynthesis. Examples are the sun, candles, etc. Elastic potential energy. Now, an example I can show you that if I stretch this rubber band, it has elastic potential energy because it is at a position and it's stretched. So that is why it's called elastic potential energy. Sound is a form of energy. Sound is produced by vibrating bodies and spreads through air or other mediums. Sound is a form of kinetic energy. Common example is our vocal cords and speakers. Chemical energy is possessed by a substance that can be released by chemical reactions. Chemical energy includes the energy contained in fuels and foods. The energy in food released by chemical reactions in our body cells. And atomic or nuclear energy. Atoms have a central region called the nucleus, which has subatomic particles called electrons that revolve around it. Nuclei, the plural form of nucleus, contain elementary parts called protons and neutrons. They are tightly bound in the nucleus by an energy known as nuclear binding energy. It is a type of potential energy. A part of the binding energy is released if the nucleus splits. This is known as nuclear fission. Nuclear reactors produce electricity by the fission of uranium nuclei. Since there are a huge number of atoms in every gram of a substance, an enormous amount of energy is released from even a small quantity of uranium, nuclear fuel, and is also most radioactive. It is used in nuclear bombs, which use the same kind of energy. Now you know the different forms of energy. Did you notice that I said in some definitions that one form of energy changes into another? To understand that, you need to know the law of conservation of energy, which says energy can neither be created nor destroyed, but can be changed from one form to another. Example are the food we eat contains chemical energy, which after digested we turn into mechanical energy, which we use to run, talk, and etc. And also the atomic energy in the sun changes into heat and light energy, and many more. And that is it for today, guys. Make sure you like the video, click the red subscribe button, and click the notification bell to be updated whenever a new video is released. So as always, this is Amateur Artist. See you in part 2.